again. So today I'll be talking about this thing we call the activity schema, which is a new way of data modeling. And talk first about, well, why did we do this? So, this is a scale conference, and I'm just going to make the case that data modeling does not scale. And I don't mean performance. I don't mean how fast is it to run SQL against a warehouse. What I mean is complexity. The amount of effort it requires to build out a end-to-end data system and maintain it can get really, really, really nasty as you grow. We had this experience at WeWork where we had hundreds of data sources, thousands and thousands and thousands of SQL queries, I don't know how many data models, materialized views, aggregations, all these things. And became a huge, huge thing to manage. And we kept doing these enormous initiatives to come up with this is the one good set of blessed data models with a great data dictionary that everyone can use. And it never quite worked out. And so I won't spend too much time on this. I'll assume most of you are familiar with a little bit about how data can go wrong. But the idea is we build out all these data models, and a lot of them end up becoming kind of similar. So in my example here of quarterly sales by region, which is okay, cool, that's a sales thing, and it's depending on a set of different tables. And then recurring revenue over time, not the same thing, right? Definitely not. But it's also kind of related to sales, and it has a slightly different definition. So it's going to depend on a different set of tables. And so every time that we want to kind of make a new metric or look at something else, that requires us to create new models, refactor old ones if we're lucky. It's not always clear what to use, and you have to read tons and tons of different SQL data just to figure out how these things are built and how they fit together. So I have this higher up, but there's no boundary between data models and data questions. And what I mean by that is you don't get to make a beautiful data model and then answer 60 different questions off of it. Generally speaking, you've got to start to build a bunch of different dependent things on top of it. And it's not entirely clear, is the SQL statement meant to just look up this beautiful data model, or is it itself a data model? So, what's one good way to fix this? We always talk about, oh, let's just have a single source of truth, right? This most amazing thing in the world. And, maybe that would solve all our data modeling problems, because as soon as someone wants to know what a sale is, they would go to that amazing, beautiful source of truth for sales that's perfectly maintained. And then it would be very quick to go and do whatever aggregation or metric they need from there. In reality, how do we actually do that? So this is kind of similar to my earlier example, but this is kind of, our life back when we were doing data work at WeWork. Was the reality is just not so simple. So you've got two different metrics, which are basically the same thing, but they came from different places and the numbers don't add up. This has happened to us a bunch of times where the CEO would just run in and say, hey, why do my sales numbers not match my head of growth sales numbers? And then some poor data person has to dig in to thousands of lines of SQL to figure out exactly what assumptions were baked into one thing versus the other, right? And so no one really necessarily can agree on what are the sales numbers for February, because that means a lot of little asterisks. So let's maybe dive into this example a bit. So what I'm going to do is show how we build this up in a normal way really quickly, and then talk about what if we built it differently, to kind of intro to how we get into the activity schema. So it's a little bit of a long intro into the concept, but we'll get there. So let's say we want to understand how people are converting based on their site visits. So we kind of want to build this table below. So, somebody viewed the website. Hopefully we know who they are. Let's assume we do. And they came from some kind of lead source. Maybe it was email, maybe it was paid, maybe it was organic traffic. And eventually they completed an order, or they didn't, right? And so we like to understand, okay, how did people convert to completing an order based upon their ad source? So how do we build this table? From this table, we can then, aggregate it up together and do it by ad source or by month or by however we like. But first, we kind of got to bring a bunch of different concepts together, right? So in the kind of normal data world that we all know, we might have, let's say we've got these three raw tables. We've got web sessions, which tell us who visited the site when. We have sales, so who completed an order when. And hopefully it's the same user, but let's leave that assumption and make it simple. And then maybe we've got another table saying, here are all the people who opened emails. So in this case, I'm not going to show the SQL. We don't have to dive into the details, but let's just say that we're joining based on UTM params. So web session has great UTM params that say, how they came. And let's say that we've got our sales table also is able to it's in the same session maybe, so our sales table has those as well. And so we're able to join the web sessions to the sales. So we know that this web session, eventually contributed to the sale. Emails, let's just say it's coming from a different system. So we'll try to be clever with our SQL, and we're going to say, okay, if they opened an email 30 minutes before that session, then we know that we can associate that particular email with that visit. And so that way, if the UTM param doesn't have anything or has organic, we can say, oh, wait, you got an email just before, so let's assign it to email. So, I'm not going to show the SQL for this, but we can kind of imagine how we built all this up. So this is where I'm going to take you guys down kind of a different path. It may not be clear immediately why we're doing this, but we're going to kind of talk about how to do this in a fundamentally different way and see where that gets us. So let's step back a moment and look at what we're doing. We're trying to put web sessions, sales, and emails, which are three very different things, basically into the same table. But one thing we can notice is that all three of them have a similar structure if you kind of look at it. Web session is someone visited a site at a certain time. A sale is someone did a sale at a certain time. And an email is someone got an email at a certain time. So what if we did all the joins that way? What if we joined on customer and time for all of them, not just the emails? Now, again, these are not the most obvious joins in the world to do, and we'll sort of get into that in a second. But what it means is that we can sort of build our marketing to sales table by kind of doing the same join on all three, if we kind of treat all three the same. So the next step to that would be, wait a second, what if literally all three of those tables were actually the same? I can picture a data structure, a table where we say, here's a customer, here's a time where they did something, and here's the thing they did. They, opened an email, they had a web session, they had a sale, and maybe some metadata that describes stuff about those things like UTM params and so on. If we did that, and again, the why isn't clear yet, but we'll get into that in a minute. So if we were to do that, then all of a sudden, we're taking one table and, we'll still have a couple different joins, but they're the kind of the same conceptual joins to build our marketing visitors to sales table. So where am I going with this is you get this one interesting layer of dependencies, this sort of magic table that I made that has all the emails, all the sessions, all the sales kind of in the same format, right? Because it's the same table. They can answer a lot of different questions. And we don't have to remodel it to do that. We just have to kind of change up our joins. So if I want to do visitors to sales with emails, that's one way to do it. Visitor to sales with emails and whether they've called us. That's another one. And then quarterly sales, right? Do the same thing, but maybe decimate the timestamp by quarter. So this is actually what the activity schema is, and this is how it's built. So the idea of the activity schema is that it's a single table with a very specific structure. And I'll talk about that structure in just a sec. And the idea is that from that one table, as long as you've got all the events that you care about, so, website visit or website session, customer order, emails, and frankly, any other number of things inside of it, then with these sort of joins over time, then you can make all the different tables you care about. All right, so what is this specifically? This doesn't show all the columns. So activity schema has 11 columns. Most of them are metadata, but the high level point is that it's a single table with the same structure. And conceptually, it's always there's a customer who we identify uniquely, either with an email or it's null if we just really don't know who they are, but we can always have a like a different identifier, which is a detail I can get into some other time. But so we have a customer. There's an activity they did, which could be, generally speaking, any interesting interaction that the customer has with the business. Completed order, viewed page, submitted a support ticket, shipped a product, or returned a product, like anything kind of relevant to the business. And as I said just a second ago, we query that table using relationships in time. And I'll talk about what is a relationship and what does that mean in just a sec. I should note there's a couple little dots here for the other columns. We have metadata columns as well because, for opened email, which email did I open? For page view, which page did I view, right? Like you have to know some stuff about these activities. So there is metadata in here as well. So like, why are we doing this? Like, what's the point? Is that we're trying to deeply separate models, what we call data models, from doing the actual queries, from pulling out actual metrics to answer very specific questions. I mentioned earlier that my experience in the data world had been that frequently whenever there's a new data question, when a business stakeholder says, oh, I really would love to know how calls, phone calls relate to people moving out. Let's say this was at WeWork. A lot of times you've got to go build new data models to go answer that question. It's not obvious how to stick all those things together. So the idea here is, we want to live in a world where we can model concepts about the business and keep them the way they are. Whenever a new question comes up, you just have to issue a new query. So that's the high level idea. And whether or not we believe that's possible, the claim I'm making is that the activity schema is designed to do that. So how does that work? So I've mentioned this a couple of times, but the activity schema table will represent all the data that you care about, meaning all the data that is relevant for analytics about a business. As I said, the activities, they're all independent and they're defined once. What I mean by independent is a given activity doesn't have any knowledge of any other activity. So the example I gave earlier with the email and so on, they don't need to have IDs to each other. So an email is just, here's the time at which a customer saw an email. Here's the time at which the customer had a web session. Those things don't need links to each other in the activity schema. You just define those concepts fully independently. And I'll briefly show how they're defined in a moment. So then once you have an activity schema built, then every query you ever want to make, any metrics you want to define, any kind of BI you want to do, any materialized views you want to make, any aggregations, all of that goes straight to the activity table. It's just query it directly with SQL and just have no dependencies. So really the structure is, you've got raw source tables, you have an activity schema, and then you've got whatever derived metric table, whatever you like, but no dependencies on models. And then, as I said earlier, no metrics or queries, they do not require changes to activities. So the benefits to this is that each thing is defined once, so it's a single source of truth. So any numbers that are meant to be the same number will actually match. If we're talking about sales per month, and we have a single place that defines a sale, a single activity says customer made an order, then any way you're going to aggregate that, it's going to match. You could say order by region, order by whatever, but of course, that's pretty clear that you're partitioning in a different way. The downsides to this, which might have been clear as I was talking about these joins over time, is that querying it with SQL directly is actually challenging. The joins to kind of put these tables together from this activity schema can be tough, and I'll explain how those are done and how we solve for that in a minute. So this is actually the activity schema, I guess, architecture diagram, if you like. You've got a series of source tables, which are the raw tables in a warehouse coming from whatever authoritative system, Salesforce, Zendesk, your own production database, Segment for your web visits, whatever that is, whatever raw data that is, that lives in your warehouse, you sync that in there through Fivetran or something. Build an activity schema from those directly, and I'll show that in a sec. And then every query you care about is going to go exactly against that activity schema table. And that's it. No other dependencies, no layers. Gives you one nice place to debug everything. Okay, so how do we build these? It turns out actually building an activity schema is actually straightforward. So all we need to do is put data into the activity schema format. So this little chunk of SQL, I'm not going to dive into it too deeply. It does show all the actual, most of the columns that we use in the activity schema. There's a couple that are computed. But you really just need to have an ID, a timestamp, a customer, some metadata. You have to have the name of the activity. So if you think about this in terms of a customer doing an activity in time, then it's actually not that hard to think about how to transform most source things into this format. So, this example is a Shopify order. So great, there's an orders table, and maybe you want to bring in discount codes to understand how to compute the total amount of money that you made from that order. That's okay, just do a couple joins. But at the end of the day, all you really need is to figure out, well, who made that order, and at what time did it happen? So, emails, same thing. CRM for Salesforce, you could look at your leads table to see when someone became a lead, when someone became closed won. The interesting thing is that a lot of data sort of represents a business, and business data is about usually a customer interacting with the business in some way. And so generally speaking, it all fits into this format. And one thing I should point out, just in case it's not clear, is that the idea of a customer is a little bit abstract. It can actually be anything. If my business was a scooter business that rented out scooters to ride, the scooter itself could be the customer, and then my activities could be, scooter took a ride, scooter was sent to maintenance, scooter was bought for the first time, right? It doesn't really matter exactly. Okay. So these simple transformations. So generally speaking, we've been running Narrator for about 4 years now, and our customers build these very quickly. They take about 25 lines on average is what we've seen. Again, because there's no dependencies from one to another, you just have to independently decide what is a completed order, and then you're good to go. One example we've seen was a customer who actually was using and migrated their completed order, their ordering system from, I forget exactly what it was before it was Shopify, but something to Shopify. And so they had built a transformation for the old system. They had built another transformation for the new system. And because ultimately the idea of a completed order has the same structure, both systems would make the same activity just at different times, and it merges seamlessly. It works really well. Okay. So kind of a big shift here. We're going to talk about, okay, well, how do we query this? Let's say that building this is straightforward and makes sense. How do we actually get real stuff out of this? So I'll probably spend about the rest of the talk talking about this. So let's say that we wanted to build a table that would tell us, per month, what was the conversion rate to completed order from visiting a website. We talked about this a little bit. This just doesn't have the emails. So, at a very, very high level, conceptually, what are we doing? The activity schema is kind of a time series table. And so we're saying, okay, let's take all the visits, and for each visit, did they complete an order during that visit? So we just have to figure out what is this equal to tell us, okay, let's get all the visits as the rows. And for each one of those rows, let's figure out, did they complete an order again? In that visit before the next visit. And if so, make a column that says, yes, they did, or no, they didn't. And then this is the table showing sort of the aggregation, which is then straightforward. So the total number of rows, which is the total number of web visits, is the total sessions. The sum of this 0 or 1 column, did they order or not, would tell you the total orders. And then the conversion rate would just be the average of all those zeros and ones. Now, the trick to all this is, well, how do we know that for a given web visit, they did an order in that visit? So for that, we actually talk about querying a little differently for the activity schema. We don't talk about it in terms of joins because all of them look similar and they're hard to sort of conceptualize directly as SQL. We actually talk them in terms of relationships. And I'm going to show a couple of these. I'm not going to go through all of them, but what we found is that we can express any kind of analysis we've ever had to do with 11 different relationships. So let me talk about one initially. So the example I just gave was using this relationship called first in between. And this is not the exact same one, but it's pretty similar. So we're saying, what's the best email campaign to get customers to order? And the idea here is, whether did someone, after having an email campaign, did they complete an order? What's the conversion rate, or did they do it or not, right? It's a very similar question to the other one. So the idea is someone receives an order, someone opens an email, and then later at some point, they may or may not have completed an order. And the question is did that open email relate to that completed order? And so we use this idea of first in between, where we say, okay, take a look at all the open emails. And then for each specific given customer, what is the first completed order between the email we just had and the next email, right? Because if it's the next email, the completed order is after that, then you want to take that one as the one that you match. So the idea here is every single row is going to be one opened email, and then the first in between completed order will add a completed order row. Or we'll add we'll add data in the completed order columns. What if they had a completed order first in between that email, meaning completed order after that email, but before the next completed email. These take a little bit to sort of understand, but I'll just talk through a couple more like really quickly. Which paywall is best at getting subscribers? You would say, okay, well, you haven't started a subscription. What's the last before viewed paywall? And in that case, you're saying, at some point, someone viewed a paywall, and I know at some point someone subscribed to something. So what's the last paywall they ever saw? And the idea here might be that, the last paywall they ever saw before that subscription happened. And so that was the most recent paywall they saw before. And you can use that as a way to say, okay, like, let's, break out all the different subscriptions by paywall this person saw. Right, that might be like another way to do it. And the point through going all these is not to understand exactly how these relationships work. It's more just to kind of say like different questions can be answered by using different ones. So, how long does it take from first site visit to be a lead? Well, give me the first ever website visit I ever had and give me the first submitted lead after that website visit. So there's two things that are hard about querying activity schema. One is kind of thinking in terms of these relationships. It's not always obvious how to sort of in your head turn data problems or data metrics or questions into this relationship format. It gets pretty easy with time, but that's the first little bit of a hurdle. And the second one is just literally writing out these relationships as SQL. I'm not showing the actual code here because it's a little bit hairy. This diagram shows us a first in between, which is, okay, I found my website visit, great. Now, which completed order am I sticking next to it, if one? So I've got to make sure I find this one and put it on the same row, but not this one right here. So joining that way can be kind of nasty. So, you want to join where it's the same activity, where the timestamp is between that viewed website timestamp, but before the next viewed website timestamp. Make sure you pick the first one in case there's more than one between the two of them. And then there's a bunch of edge cases too, like what if you don't have any more viewed websites events? The actual SQL is right here in tiny, tiny fonts. Again, like let's not look at it. It's crazy. But one very interesting thing about it is that because there's only 11 and they're all very similar, they're extremely easy to auto-generate. Once you've written one once and you're very happy with, okay, this is really representing what first in between means, then every other sort of data question you've got that uses first in between can just generate that query, right? The only difference really is going to be the activity ID and any like filters you want to add onto it. This isn't a pitch narrator or app, but the point is to say with an activity schema, you can build a UI that will help you query it, help you build out these relationships and do whatever you need without having to dive into the SQL to do it. And we found actually that was sort of the best way to use the activity schema in practice. Okay, so that was a lot. So, what have we really sort of talked about here is you can create a single source of truth by creating activities, the concept of activities and the activity schema together. Every business concept you have, regardless of what it is, you only need one activity per concept, and you can have as many, concepts as you like. They're easy to write, they're easy to debug because they're independent. There's only one of them, there's no dependencies between them. And then, on the other side of things, separating querying from modeling, once you've got your data models as an activity schema, then you run all your queries on top of that. Any interesting analysis you want to do with conversion rates or anything else, you're going to want to relate activities together using one of these 11 relationships. And again, using a web tool or a UI of some kind is probably the best way to do this. So for best results, auto-generate these queries. So, what happens if this becomes a thing? If everyone has an activity schema, there's a lot of kind of funny, interesting things that come out of this. So activity schema, because it's a fixed format, everyone will have the exact same table for their data. So everyone's data models will differ, right? Everyone has different ideas of what is a sale and different ways to model it and different ways to get it into the activity schema and different activities, but the structure is actually the same. And because the structure is the same, I'm not talking about this today, but a narrator we've been playing a lot around with auto-generating analysis. We are able to say, okay, just tell us which is the activity name that represents an order and which is an activity name that represents, let's say your ad spend. And we can sort of automatically build you customer acquisition cost because we know the data structure, so the SQL we can issue is going to work. So yeah, this is a small sort of, I just mentioned that a second ago. We can quickly automatically build out auto-generate analysis based on sort of issuing a bunch of SQL that we've pre-built on the activity schema because it's the same format. This is something we've done live, but again, like we're not talking about this thing. We just mostly want to talk about activity schema. One last thing is I think I forgot to mention is, activity schema has a website. It's an open standard that, came from Narrator, that came from our experience building this company, but that we are very happy to sort of have other people use and pick up and learn about. So, feel free to visit it. There's a spec on the site. I'm always happy to talk about it. So feel free to email me with questions, comments, thoughts. If you don't believe it's possible or that it sounds crazy, love to hear that too. But yeah, so I think we're just about at the end of time. So I'm gonna switch over to the question and answer tool.